Dear students, in this video on kinematics, we will study motion in one dimension with position time graph, velocity time graph and numerical problems. So let us begin with motion in one dimension. Now, it is also called rectilinear motion or translational motion. So, the motion confined along a straight line is called वन डायमेंशनल मोशन. जैसे अगर एक स्ट्रेट रोड पर कोई व्हीकल है तो वो स्ट्रेट रोड पर कार आपकी इधर जा सकती है या इधर जा सकती है. इट विल बी मोशन इन वन डायमेंशन और रेक्टिलिनियर मोशन और ट्रांसलेशनल मोशन. So let us consider motion along x-axis only. Now for that we fix a point as origin. This has shifted. We fix a point as origin and one side is taken as positive plus x. The other side is taken as negative as minus x. Right? So all the displacement along plus x-axis are taken as positive and all the displacements along minus x-axis are taken as negative. So this is like a number line. And one more thing, displacement is always final position minus initial position. Displacement delta x, कोई भी change है, it is change of position. So कोई भी change हमेशा फाइनल में से इनिशियल को माइनस करके मिलेगा आपको. सो डिस्प्लेसमेंट इज फाइनल पोजीशन x2 माइनस इनिशियल पोजीशन x1. राइट. सो लेट अस टेक सम एग्जांपल्स हियर. if at t is equal to 2 second x1 is 10 meter and t is equal to 10 second x2 is 50 meter, then delta x displacement is final position x2 minus initial position x1. now final position 50 meter है यानी कि वो इधर 50 meter है. initial position 10 meter है यानी कि वो ये 10 meter है. so displacement यहाँ से 10 meter से 50 meter की तरफ इधर हो रहा है displacement. It has to be positive. और 50 minus 10 is 40 meter. Positive है towards right side along plus x-axis as I have shown you. And see, delta x is positive along this direction. And now let me take one more example just to clarify it. If at t is equal to 2 second x1 is 10 meter and t is equal to 10 second x2 is minus 30 meter. यानी कि स्टार्टिंग टाइम पर आप 10 मीटर पर हैं और पॉजिटिव साइड में हैं और 2 सेकेंड पर और 10 सेकेंड यानी कि थोड़ी देर बाद आप माइनस 30 पर पहुंच गए. 10, 20, 30 माइनस 30 पे पहुंच गए तो आपका मोशन इधर की तरफ हो रहा है. ये माइनस एक्स एक्सिस की डायरेक्शन में हो रहा है. So displacement will be negative. Now here displacement is x2 minus x1. Final position minus initial position. Now final position is minus 30. Initial position is 10. So minus 30 minus 10 that is minus 40. So final displacement हमारा minus negative आया है. It is along minus x axis towards left side. So negative. Now I can give you some more examples. Supposing say you start at this point 50 and then you move to this point 20. Move along this direction. आप पूरे टाइम ओरिजिन की पॉजिटिव साइड में ही हैं लेकिन आपका मोशन हो रहा है नेगेटिव एक्स एक्सिस की तरफ. सो दिस इज अ नेगेटिव डिस्प्लेसमेंट. बिल्कुल ऐसे ही आप सपोजिंग कि आपने -60 पे स्टार्ट किया और आप -60 से -20 पे पहुंच गए। तो यहाँ से स्टार्ट करके अगर आप इधर जा रहे हैं, आप पूरे टाइम नेगेटिव साइड में हैं, फिर भी आपका डिस्प्लेसमेंट पॉजिटिव है, क्योंकि ये डायरेक्शन है प्लस एक्सिस की डायरेक्शन। सो दैट यू शुड अंडरस्टैंड। ओके, नाउ let us take some graphs to study motion. So position time graph. Now there are certain rules or conventions that we follow. So for a graph, independent variable is taken on x-axis and dependent variable is taken on y-axis. तो जो भी independent variable है वो x-axis पर और dependent variable को लेते हैं y-axis पर। Now, position is a function of time. Position जो है वो time पर depend करता है। तो time is taken on x-axis because time is independent and position is taken on y-axis because position is dependent. Time की वैल्यू कुछ भी हो सकती है, independent है, उसको हम x-axis पे लेंगे, और position time पर depend करता है तो position को हम y-axis पे लेंगे। So let us look at the first graph here. Now see, here position on y-axis, time on x-axis, and this graph is a parallel line which is parallel to time axis. So supposing कि ये position है say 10 मीटर, तो that means किसी भी time पर ऑब्जेक्ट की पोजीशन जो है 10 मीटर ही बनी हुई है। सपोजिंग कि ये 2 सेकेंड पर 10 मीटर पर है, फिर 10 सेकेंड पर भी 10 मीटर पर है, 20 सेकेंड पर भी 10 मीटर पर ही है, तो ऑब्जेक्ट जो है अपनी पोजीशन बदल ही नहीं रहा है। सो इट इज़ स्टेशनरी और इट इज़ एट रेस्ट। सो दिस ऑब्जेक्ट इज नॉट इन मोशन, इट इज़ एट रेस्ट। नाउ लुक एट दिस वन हियर। See, the graph, position time graph is a straight line, and you see that in equal intervals of time it is covering equal distances. जैसे यहाँ से यहाँ तक इस इंटरवल में इसने इतना डिस्टेंस कवर किया है, फिर अगले टाइम इंटरवल में यहाँ से यहाँ तक फिर इसने इतना डिस्टेंस कवर किया, ये वाला, फिर अगले टाइम इंटरवल में फिर इसने इक्वल डिस्टेंस कवर किया है। So here the object is covering equal distances in equal intervals of time, and this is called uniform motion. So definition of uniform motion is a body covers equal distances in equal intervals of time, however small the time interval may be. आप टाइम इंटरवल कितना भी छोटा ले लो, छोटे से छोटा टाइम इंटरवल ले लीजिए, अगर उसमें डिस्प्लेसमेंट इक्वल होता है तो उसको हम बोलते हैं यूनिफॉर्म मोशन, एंड इट इज़ अ स्ट्रेट लाइन। ना स्ट्रेट लाइन ऐसे भी हो सकती है, ऐसे भी हो सकती है, ऐसे भी हो सकती है, कैसे भी हो सकती है, इट हैज़ टू बी अ स्ट्रेट लाइन, एंड दिस इज नॉन यूनिफॉर्म मोशन। सो अलग अलग टाइम इंटरवल में अलग अलग डिस्प्लेसमेंट दिख रहे हैं आपको, सो इट इज नॉन यूनिफॉर्म मोशन। एंड नाउ velocity from xt graph. Now if we have this position time graph or xt graph, look at it here, a straight line. See here, in first 4 second displacement is 0 to 5 meter. In next 4 second displacement is 5 to 10, again 5 meter. In next 4 second 8 to 12 displacement is from 10 to 15, 5 meter. So equal distances in equal intervals of time. Now we wish to find out velocity from this position time graph. So for this you can choose any 2 points on the graph, like I have taken points A and B, and complete a triangle like ABC. Now and let us take this angle as theta. The graph is making angle theta with x-axis or time axis. So if this angle is theta, this angle will also be theta only. And now take AB as any 2 point on the graph, and you know that velocity is displacement upon time taken. Displacement is x2 minus x1, final position minus initial position, upon time taken is final time minus initial time, t2 minus t1. Now x2 minus x1 इस ग्राफ में देखो इनिशियल पोजीशन तो ये वाली है, ठीक है, और फाइनल पोजीशन ये है पूरी यहाँ से यहाँ तक. तो x2 माइनस x1 बच गया सिर्फ यहाँ पर ये वाला. दिस इज x2 माइनस x1, दैट इज BC. So BC is displacement, and AC, the final time is 12, initial time is 4. So total time interval is AC, as we can see, right? And for this triangle, ये जो right triangle हमने लिया है, इस right triangle में BC is height and AC is base, and this is a right triangle. So height upon base or altitude upon base for a right triangle is called slope of the hypotenuse AB. So this velocity V is BC upon AC, height upon base, and this is slope of this line AB, right? And this BC upon AC is also equal to tan theta. So I can write velocity V is equal to tan theta is equal to slope of AB. Now this AB is a line segment along this graph. ये जो AB है वो इस ग्राफ का ही एक पार्ट है, तो जो स्लोप AB का होगा वो पूरे ग्राफ का होगा. So we can generalize a relation as velocity of a graph, velocity from xt graph is slope or gradient of position time graph. Look at it. Velocity is equal to slope or gradient of position time graph. Now this has become a general rule. आपके ग्राफ की शेप कुछ भी हो, उस ग्राफ का जो स्लोप है वो उस ऑब्जेक्ट का वेलोसिटी देगा, एंड इट इज ऑल्सो इक्वल टू दिस tan theta. The slope is tan theta. So from here, if I wish to calculate the velocity, then you can see that this BC is 15 minus 5, that is 10, upon AC is 12 minus 4, that is 8. So 10 upon 8 meter per second. You can simplify it, right? And now let us take some more examples. The same graphs here. For stationary object, velocity V here is equal to tan theta. Now the slope of this line is 0. Slope of this line is 0 and tangent 0 is 0. So I can show this as slope also. So since slope of this line is 0, the velocity of this graph is 0. And if I take any non-uniform motion, position time graph हमने non-uniform motion लिया है, और इस point A पर हम निकालना चाहते हैं velocity. So I have, this rule applies everywhere. ये जो हमने कहा slope of position time graph, ये सब जगह applicable है, इस ग्राफ के लिए भी. So how do we find out a slope? Draw a tangent at the given point. जिस पॉइंट पर आपको वेलोसिटी निकालनी है वहां पर आप एक टेंजेंट ड्रॉ कर दीजिए. टेंजेंट इज अ लाइन विच टचेज द कर्व इन वन पॉइंट ओनली. टेंजेंट वो लाइन है जो इस कर्व को सिर्फ एक पॉइंट पर टच करेगी. सो यू कैन सी दैट this angle is making this tangent is making angle theta with x-axis. So its slope is given by tan theta only. So here the velocity is equal to tan theta. And let me take one more. Now here in this graph the slope is negative. Here the slope of this graph is negative, so here the velocity is negative. आप अगर इसको थोड़ा सा और okay, no problem. If you can produce this forward, अगर आप इसको थोड़ा सा आगे इधर बढ़ाएंगे तो आपको ये वाला जो एंगल है वो नेगेटिव एंगल मिलेगा. एंड सो for this line the slope is negative, velocity is negative. Now velocity time graph. You have to learn to read the graphs. So here look at it. Here the velocity is constant. Just see, at time t is equal to 0, supposing the velocity is say 5 meter per second. So इस टाइम पर भी if it is 2 सेकेंड, इस टाइम पर भी velocity 5 मीटर पर सेकेंड है. आपने थोड़ी देर बाद देखा 20 सेकेंड पर, तब भी velocity 5 मीटर पर सेकेंड ही है. So velocity is not changing. Velocity is not changing means the body is in uniform motion. It is not stationary. It is in uniform motion. And let us look at this situation here. Now, here the velocity is not constant, but what is happening? Velocity is increasing. Look at this side is velocity. Velocity is increasing at a constant rate. And constant rate means the rate of change of velocity is called acceleration. So this is a graph for uniform acceleration or constant acceleration. So straight line VT graph gives uniform acceleration. And now see, if we have, this is non-uniform acceleration. If the line is a curved line, this is non-uniform acceleration. And here look at it, this is also a straight line, but here the slope is negative, and this is retardation or negative acceleration. See, this is a straight line. So it is uniform acceleration only, but uniform negative acceleration, and negative acceleration is also called retardation. So now, how do we find out acceleration from velocity time graph? So here we have velocity time graph, a straight line. Same method, choose 2 points on the graph and complete this triangle ABC, and you see, take AB as 2 points on graph, and you know that acceleration is change in velocity upon time taken. Now change in velocity is v2 minus v1, final velocity minus initial velocity. Time taken is final time minus initial time. And if you look at it from here, this is the initial velocity 5, the final velocity is 15, and the change in velocity is this one, BC. So change in velocity is BC, and change in time is equal to AC. Look at it. For this triangle, for this side, the change in time is equal to this 12 minus 4, AC. So for the given triangle, right triangle ABC, this BC upon AC, height upon base, is slope of hypotenuse AB. So acceleration is BC upon AC, that is slope of AB, and it is also equal to tan theta. So acceleration is slope of AB. Now this AB is a line segment along the given graph. तो acceleration इस पूरे ग्राफ के स्लोप के बराबर होगा. So now we get a general relation that acceleration is slope or gradient of velocity time graph. So अब अगर आपसे पूछा जाए कि आप वेलोसिटी टाइम ग्राफ से एक्सेलरेशन कैसे निकालेंगे, तो दिस मस्ट बी योर आंसर बाय फाइंडिंग द स्लोप or gradient of velocity time graph. Now, for this particular case, say this BC is equal to 15 minus 10, that is 10. Velocity, change in velocity, upon AC is equal to 12 minus 4, it is 8. So 10 upon 8 meter per second square. You can simplify it. So this way you can calculate velocity, and you see here. Now look at it. Now for uniform motion, the graph is a straight line parallel to time axis. Its slope is 0, so acceleration is 0. For a graph like this, velocity time graph, you can find out slope this way, and here acceleration is equal to tan theta, slope of this tangent. So अगर आपके पास नॉन यूनिफॉर्म मोशन है तो जिस पॉइंट पर आपको एक्सेलरेशन निकालना है उसी पॉइंट पर आप एक टेंजेंट ड्रॉ कर देंगे. सपोजिंग आई वांट टू फाइंड आउट एक्सेलरेशन एट दिस पॉइंट, तो हम यहाँ पे टेंजेंट यहाँ पर ड्रॉ करेंगे और तब इसका स्लोप अलग हो जाएगा. आप देखिए इसका स्लोप कम है, और अगर इस पॉइंट पे चाहिए तो हम टेंजेंट यहाँ ड्रॉ करेंगे और इसका स्लोप अब ज़्यादा हो गया. एंड नाउ हियर, now this one is a case of negative slope, so here the acceleration is negative or it is retardation. And now how do we find out displacement from velocity time graph? So first let us consider a case of uniform motion, and then we can generalize it here. Oh. Okay. Some shifting has occurred. This point should have been C, and this time is T2. Okay. So if this is uniform motion, you know this is the graph is parallel to time axis. So for uniform velocity, the displacement is velocity into time, you know that, and this velocity is equal to AD. As you can see, the uniform velocity is equal to AD. So velocity is AD and time from T1 to T2 is equal to CD. So for this rectangle, if this point is B, if you look at this rectangle, then this AD length into breadth gives the area of this rectangle. You getting area of the rectangle? No? So that means the area of rectangle gives the displacement. और ये रेक्टेंगल का जो एरिया है इस ग्राफ के नीचे वाला एरिया है, तो हम इसको ये भी कहते हैं कि इट इज एरिया अंडर वेलोसिटी टाइम ग्राफ. सो हियर आई गेट अ जनरल स्टेटमेंट दैट डिस्प्लेसमेंट is area under velocity time graph. This is area under velocity time graph. Velocity time graph और time axis के बीच में जो area आ जाए वो होगा displacement. Now let us see how we generalize it. That was a very specific case. अब हम इसको generalize करेंगे. So displacement for a non-uniform motion. Say here. Rectangle का area निकालना easy था. अब यहाँ पर कैसे करना है? So let us consider two cases. This is we want to find out displacement between time t1 and t2. ये displacement हमें निकालना है. So for that what we do is we will divide the whole area into very thin strips. इस पूरे एरिया को हम बहुत छोटे छोटे, पूरे टाइम इंटरवल को बहुत छोटे छोटे हम टाइम इंटरवल्स में डिवाइड कर देंगे. एंड देन वी विल कंसिडर अ very small time interval. Look at it. So I have considered a very small time interval dt here. और इस टाइम इंटरवल के लिए थोड़ी देर के लिए हम मान लेंगे कि हमारी वेलोसिटी कांस्टेंट है. सी दिस टाइम इंटरवल इज एक्सट्रीमली स्मॉल, तो इसके लिए हम इस वेलोसिटी को कांस्टेंट मान सकते हैं. एंड देन दिस पॉइंट, ये वाला पॉइंट और ये वाला पॉइंट, ये दोनों बहुत क्लोज होंगे एंड दिस विल बी जस्ट लाइक अ रेक्टेंगल. सो द डिस्प्लेसमेंट इन दिस dt टाइम विल बी दिस एरिया ऑफ दिस थिन स्ट्रिप, राइट. अब इस थिन स्ट्रिप का एरिया हम ले लेंगे एज डिस्प्लेसमेंट इन दिस टाइम इंटरवल dt, और ऐसे जितने छोटे छोटे हमने स्ट्रिप्स बनाए हैं उन सब के एरियाज को ऐड कर देंगे तो हमको टोटल डिस्प्लेसमेंट मिल जाएगा. सो लेट अस सी हाउ वी डू इट मैथमेटिकली. सो द वेलोसिटी and see, let me mark these points as A, B, C and D, right. So we have got this quadrilateral ABCD which is almost like a rectangle because points A and B are very close and dt, time interval dt, is approaching 0, extremely small. So let's see how we write it. Now to find displacement between time interval t1 and t2, the time interval is divided into extremely small time intervals dt. Velocity v can be taken as constant for time interval dt. So displacement for time interval dt, that is dx, is area under vt graph, जो अभी हमने किया. So dx is equal to area of this rectangle ABCD, that is velocity v into dt. Just look at it. Okay, here this is like a rectangle, see. So its area will be this side into this side. Now this side is velocity and this side is time, so that becomes area of this strip. So now the total displacement, see, for the thin strip the displacement is v into dt. So total displacement will be sum of all the areas of all the thin strips, that is area under vt graph. इस पूरी लाइन के नीचे, ये जो लाइन है यही vt ग्राफ है. सो इस लाइन के नीचे का ये पूरा का पूरा एरिया आ जाएगा. ये सारे थिन स्ट्रिप्स को हम ऐड करेंगे तो सारा एरिया इसके नीचे वाला आ जाएगा between these two time intervals. And see, how do we represent it mathematically? Now the mathematical way of writing it is integration. As I've told you, integration means adding small pieces between any two given limits. So that is integration. So the total displacement, this dx, total displacement x, is equal to integration of this right side v dt, t1 to lower limit t1, initial time t1, upper limit t2, initial time t2. So integration from t1 to t2 v dt, and that is area under velocity time graph. Oh, sorry, this is area under, okay, this is area under velocity time graph. Sorry, यहाँ पे time is missing here. Area under velocity time graph, VT graph. Okay, and now let me take, so let us solve a numerical problem based on this VT graph. So here we have been given a VT graph You can see with different velocities and accelerations. Different segments are marked here. So this is the graph, and let's see what all things we have to do from here. So now from the given graph, find acceleration for part OA, AB, BC, CD, DE and EF. We have to find out acceleration for part OA, AB, BC, CD, DE and EF. Acceleration for every part. And we know that acceleration from this velocity time graph is given by the slope of the graph. So we have to find out the slope of this line OA, slope of AB, slope of BC, this one and this one. We have to find out slope of each segment. And if you look at it at any segment, if I'm talking about OA, then its slope is height AB, which is equal to 10 upon base, and this base will be equal to 8 seconds, 0 to 8 seconds. So this is 10 upon base 8, 10 upon 8. For part AB, the slope of this part AB is 0, so acceleration is 0. For part BC, the height is, this is equal to 10 and base is from 12 seconds to 16 seconds. This is 16. 12 seconds to 16 seconds. So base is 4. So you will get this 10 upon 4. 10 upon 4. But only thing is that this is negative slope, because this final velocity is 0, initial velocity is plus 10. Similarly, we can find out slope of this one. This is also negative slope. Slope of this part is 0 and slope of this part is positive. You see? This part is on negative side of velocity, but its slope is positive. It is parallel to this one. And so acceleration for this part will be positive. So let us solve them now. Okay. So for each part, the relation is acceleration is change in velocity upon time taken, v2 minus v1 upon t2 minus t1, or slope of graph. So part OA, first part, v2 minus v1 is 10 minus 0 time 8 minus 0 is equal to 5 upon 4 meter per second square. For part AB, acceleration is slope of AB, acceleration is 0 meter per second square. For part BC, final velocity is 0, initial velocity is plus 10, time is 16 second minus 12 second. So you get minus 10 upon 4, or this is minus 5 upon 2 meter per second square. And for part CD, the final velocity is minus 5, initial velocity is 0, time 20 minus 16, minus 5 upon 4, minus 5 upon 4 meter per second square. For part DE, flat part, acceleration A is final velocity minus 5 minus initial velocity minus 5 upon 24 minus 20, time difference, and this is 0 upon 4, that is 0 per meter per second square. And for the last segment EF, final velocity is 0, initial velocity is minus 5. So 0 minus minus 5 upon final time minus initial time, and that is 5 upon 4 meter per second square. So it is a positive acceleration. So we have calculated all the accelerations, and now let us move to the previous part once again. And now what we want is displacement from t is equal to 0 to 16 second and t is equal to 16 to 28 seconds. We have to find out the displacements. See, displacement from t is equal to 0 to t is equal to 16 second, and t is equal to 16 to t is equal to 28 second. Now you see that displacement, this is 16 and this is 28. So time marking has shifted. Displacement is area under velocity time graph. So the first displacement will be this one, and this will be positive displacement. Second displacement is going to be this one, and this will be negative displacement. Now, if you look at it, this is a trapezium, and here see this side and this side are parallel. For trapezium, one pair of opposite sides are parallel. Now, this base B1 for this trapezium is 16, as you can see, 4, 8, 12 and 16. And the other base is, see, 8 second to 14 second, parallel to this. This is 4. So, it is 16 plus 4, sum of opposite parallel sides, half into height. Now, the height of this trapezium, you can see from here to here, it is parallel to this, 10. So, height is 10. So, the area will be half B1 plus B2 into height, which is 10 and positive. Similarly, for this one, the base is from 16 to 28. This is 28. So, this base is 16, this base is 12, and this one is 20 to 24. So, this is 4. So, here the area will be equal to half base 12 plus 4 into this height is minus 5, equal to this one, parallel to this one, into 5. And you can calculate this area also. So, that's what we are going to do for this part. So, comes the displacement part, you see. So, for time t is equal to 0 to 16, displacement is area of the trapezium, half b1 plus b2 into h, that is half 16 plus 4 into 10 is 100 meter. For time 16 to 28 second, same formula, the value of base is 12 and 4, and this displacement is negative, into height is 5, and that is minus 40 meter. And now the total distance covered, see, distance is always positive, so total distance covered will be 100 plus 40, 140 meter, and displacement is 100 minus 40, 60 meter, and average speed will be total distance upon total time, 140 upon 28 second, 5 meter per second, and average velocity is total displacement upon time taken. Now, total displacement is 60 meter, time taken is same, 28 second, and you simplify it, you get 2.14 meter per second. And the next part is to find instantaneous acceleration at t is equal to 6 second and t is equal to 16 second. Now, this t is equal to 6 second is part of uniform acceleration. So, it will be same. Similarly, for t is equal to 26 seconds, let us have a look at the graph once again. See, here the question is instantaneous acceleration at t is equal to 6 second and t is equal to 26 second. Now just think कि आपका t is equal to 6 second यहाँ कहीं आएगा इस पॉइंट पर, और ये पॉइंट इस यूनिफॉर्म एक्सेलेरेशन का पार्ट है, तो जो एक्सेलेरेशन इस पार्ट का होगा वो t is equal to 6 second पर भी वही होगा, and acceleration for this part is 5/4 meter per second square you have calculated. Similarly, for t is equal to 26 second, see this is 28 second, this is 24 second. So 26 second is somewhere here, and this is part of this graph. तो जो एक्सेलरेशन इस लाइन का है वही एक्सेलरेशन 26 सेकेंड पर है, विच इज़ ऑल्सो सेम 5/4 मीटर पर सेकेंड स्क्वायर. सो आपको ये प्रॉब्लम दिया है so that you understand the concept of instantaneous acceleration also. And the last part is to draw acceleration time graph. Now you have calculated acceleration for each part, and then you can plot a graph between acceleration and time. So you have values for all the parts. So we are moving to acceleration time graph straight away. The last one. Yeah. So now we are taking acceleration on y-axis, time on x-axis, and all the calculations are already done. See, all the calculations are already done. For first part, the acceleration was constant and plus 5/4 meter per second square. For part AB, acceleration was 0, as you can see. For part BC, acceleration was minus 5/2 meter per second square and constant. For part CD, acceleration was minus 5/4 meter per second square and constant. For part DE, acceleration was 0. For part EF, the last segment, acceleration was positive and equal to 5/4 meter per second square. So that's how आपने सारे कैलकुलेशंस किए हुए हैं तो उसको आप ग्राफ पर दिखा सकते हैं. And with this I come to the end of this video. You should try to do as many graphical problems as possible to understand the concept better. Thank you for watching.